This is 9.1a, all about simplifying and evaluating rational expressions. Right, so we have a new function family here, rational expressions, and they are all different group. We'll look at their graphs here in a bit, but later in this unit. But what you need to know right now is that a rational expression, it just means like a fraction. Okay. Okay. So some examples: 15 divided by x plus 1. Notice how there's a numerator and a denominator, and our denominator has x plus 1. Okay. The golden rule here is that you can't separate addition or subtraction that's in the denominator. Okay, you can only separate multiplication and division. Okay, so it's a ratio of two polynomial expressions. Think fractions. Here are some examples. We can have them in factored form like this: x minus 2 times the quantity x plus 4. The parentheses are important. Okay, we could think about this x plus 4 on the bottom as a factor, and we could actually cancel those two out because there's multiplication. It's the same thing as if I say 2 times 4 divided by 4, right? I could cancel out those 4s on the top and the bottom, and I'm just left with 2. That's kind of what this looks like, okay? Remember that division by 0 is undefined. You may be asked to simplify, which means to cancel out common terms that are multiplied in both the numerator and the denominator, like that x plus 4 that I just showed you, okay? So something else we want to keep in mind is that, division by 0 is undefined. So what value or values for x would make this first expression be undefined? What if I plugged in, let's say, what if I plugged in 0? What if I plugged in 0 for x? Then I would have 4 times 0 divided by 0 plus 1. And then I'd have 0 divided by 1, which is equal to 0. So I'm not undefined when x equals 0. That's fine. What about if I try 2? What about if I plug in 2 for x? 4 times 2 divided by 2 plus 1. Well, then I get 8 divided by 3, which is a number. It's a fraction, right? 2.66666 repeating. Okay, so 2 is fine, 0 is fine. All right. The key here is this denominator, okay? That denominator cannot be equal to 0. So I can get right there by saying, hey, denominator, you can't equal 0, and then figure out what value would make it be 0. It would be when x is -1. So -1 is the value that would make the expression undefined, okay? -1 would make, see, x equals, to be more specific, x equals -1 would make 4x over x plus 1 undefined. Okay, what about this one? This one we got to think about how do we even evaluate? Like, how do we even plug numbers in here before we think about being undefined? Say we try 0. 0 is always everybody's favorite place to start. Okay, say we try plugging in x equals 0. What does that look like? -3 times 0 times 0 plus 2. All I'm doing is I'm just putting zeros in for these x's. Okay, and that's divided by 0 minus 1 times 0 plus 4. And if you simplify some of these calculations along the way, that's fine. Just be careful. Be careful when you're plugging this in. Okay, -3 times 0 times 2. It's going to give me 0 on top. And then I have -1 times 4. So I really have 0 divided by -4, which evaluates to 0. It's not undefined. Okay, so x equals 0 is okay. What if I try x equals 1? Let's see. Let's try 1. Plug in 1 anywhere you see x. And maybe you've already noticed it, right? This 1 minus 1 is going to give us 0. So our numerator would be -3 times 1 times 3, which would give us -9. And then down here we would get 0 times 6. So we have -9 over 0, which is undefined. So x cannot be equal to 1. We're not done yet, though. There's another one, okay? any values that make the denominator equal 0 would make the expression undefined, okay? So x also cannot equal -4. Okay, if it's helpful for you to write that down. Any values that make the denominator equal 0 would make the expression undefined. All right, so when we're in factored form for our denominator like this, x minus 1, x plus 4, what we could really do, guys, we could just take, oh my gosh, my pen is doing some crazy things. You could just do this. Take your denominator, set it equal to 0. Remember from unit 5, right? X minus 1. Oh my goodness. If we have something in factored form and we're setting it equal to 0, then we can set each factor equal to 0, okay? So meaning 1 and -4 are the two values that would make our denominator equal 0. So x equals 1, x equals -4 would make the expression undefined. Okay? So we may have to simplify first. Okay? So you may have to factor your denominator first. May have to factor your numerator and your denominator first. Okay? So x squared, that can't be factored at all, but this denominator, x squared plus 2x plus 1, that can be factored into x plus 1 times x plus 1. And then now we can just look and see, hey, if we set that little denominator equal to 0, then -1, x equals -1, would make the expression undefined. Makes expression. Okay, set your denominator equal to 0, remove those values. What about this one? What about this one? Just set your denominator equal to 0, okay? X minus 6, x squared minus 9. That means that x equals 6. And remember here, x squared equals 9. Because we are introducing the square root into the equation, we create the possibility for a plus or minus, so we need a positive and -3. So x equals 6, x equals 3, x equals -3, all make the expression undefined. Okay? And then we can take a step back now. Evaluating should be very straightforward for us. Okay, find g of -1 if g of x equals 9x plus 3 over 12x plus 3. So it's just saying, hey, let's plug in -1 for x. That's what evaluate means. It means you're getting a value. Okay, -9 plus 3 gives us -6. -12 plus 3 gives us -9. So we end up with, should be 2/3. Okay. All right, find h of 7. 7 squared minus 11 times 7 plus 24. I'm telling you guys, just take some time when you're plugging these in. It's so easy to make a silly sign mistake. 49 minus 77 plus 24 divided by 6. So we can plug that in. Let's see, 49 minus, I believe, minus 77 plus 24, and we want that to be divided by 6. Oops. And we should get -2/3. Okay, that's it. Take a look at your practice and let me know what questions you have.